LIFT stands for Laser-Induced Forward Transfer. It means we use the laser to transfer a type of nano-ink from a donor substrate to receiver substrate. And the technology is interesting because we can have a wide range of nano-ink. Currently we are focusing on graphene ink, which can make conductive traces and circuits. And in terms of receiver substrate, we are trying to test different materials, like both organic, non-organic, like paper, bamboo strips, as well as like tattoo, temporary tattoo paper. So we want to test this technology and see what kind of interactive devices we can make.
LIFT printing is relatively new technology, and we have been developing it for a few years now, and we are looking for application, and printing sensors or conductive track in general is one of major applications, and this can be done on any substrates for polymer electronics, as I mentioned already, for sensors. You can print on any substrate and any ink. Doesn't matter what is the viscosity, which makes it quite different, and this is a major advantage compared with inkjet printing and screen printing. Hopefully through this project we can make accessible to people without special background in the technology area.
The other advantage is the selectivity of the laser. So we can print quickly any design which you think by laser, because it's just the mirrors which define the beam path of the laser and defines the design, and it's so quick. And the last one is the sintering. This is what we just found out during our latest experiment, and this is sintering is a process of heating up the material to improve the electrical conductivity, and this is usually being done in furnaces. But what we did and we discovered is we can do the sintering also with the laser. So after printing the material, we just remove the donor and we process again with the laser to heat up the material and improve the conductivity, which we saw we have comparable electrical conductivity compared to conventional sintering methods.
So it could be used for remote surgery. It could be used for education, like students making their own sensors and circuits. It could be used for research, like hand tracking, and also industry that use hand tracking for remote operations, or playing games in VR. So the technology is interesting in terms of sustainability, because graphene, the conductive ink we are focusing on, it's conductive, and we can print on any kinds of substrate, and that can be biodegradable. So now we are using a lot of electronic devices, and e-waste is a problem. For example, people use their phone only for 2 years and then get a new phone, and we have many more gadgets compared to the past. So we can imagine lay people creating their own interesting interactive devices at home using biodegradable substrate, and use it and then put it in their backyard, and it will biodegrade. So that's one of the advantages of the LIFT.